So hello and welcome to the continued coverage of the walkthrough series, and in this episode we are going to be looking at 9618 variant 41 of October, November 2023, and we are doing the Java implementation for question number 2. Alright, so let's go and look at what we have here. Alright, so a linear queue is implemented using the 1D array queue. The index of the first element in the queue, in the array, is 0. Then a item 1 wants us to write program code to declare the queue, the head pointer, the tail pointer, which are essentially global variables. So let's switch to the code and see that in action. So you see that on lines, let's make sure that I have all my code in focus here. Alright, so on lines 11 to 14, that's where I have the global declarations for my the specified variables here, that is the queue, the head pointer, the tail pointer. And then I did also take the liberty to declare the final, the maximum size of my queue to be 50, so that I don't have to use the hard-coded values, because I know that my queue is going to be of size 50, so that I might as well just say there is a constant in line 11, so that's what I'm doing. Then of course you copy the code and paste it inside of the evidence document. Moving on to A item 2, the procedure in queue takes a string parameter. If the queue is full, the procedure outputs a suitable message. If the queue is not full, the procedure inserts the parameter into the queue and updates the relevant pointers. Okay, so let's go ahead and look at the enqueue method. Alright, so what we have going on, the enqueue method starts at line 21 up to line 34. So the first thing that we need to do is to take a parameter on line 21 of type string, and we're calling it ID. Then the first thing that we need to do before you even attempt to enqueue anything is to check to see if the tail pointer is currently pointing at the maximum size, which is 50. In which case the queue would be full, so we can just output the value. We can output queue is full, is it, like what we're doing on line 23 there. Then we simply return control to the main method, or whatever method we would have called queue on line 24 there. Then should we have space to enqueue, then it means that we need to pass our queue pointer. Rather, we need to take our ID variable that was passed as an argument and store it at the current index position inside of the queue where the tail pointer is pointing. So that's what we're doing on line 27. Then we are going to check to see if the head pointer is currently pointing at -1, in which case we would want to set the head pointer to 0. Then of course we would need to increment the tail pointer so that it points to the next empty slot. So we do that on line 34 there. So with that being done, you can go ahead and copy the code and paste it inside of the evidence document. Moving on to part 3, we are to write function code for a function called dequeue, which checks if the queue is empty. Then if the queue is empty, the function outputs a suitable message and returns the string empty. If the queue is not empty, the function returns the first element in the queue and updates the relevant pointers. So let's go ahead and look at that in action. So you see that on lines 37 up to 50, that's where I have my my dequeue method implementation. So you see the method here that this one doesn't take any arguments. So we go ahead and check on line 38 to see if the head pointer is currently equal to -1, or if the head pointer is currently pointing at the same position as the tail pointer, in which case we would know that the queue is now empty. Then we simply return empty. Otherwise, we are simply going to take the element that is being pointed at by the head pointer inside of the queue, then store it inside of that ID variable on line 43 there. Then of course we need to update the value for the head pointer. Then if the head pointer is now greater than or equal to the tail pointer, it means that our queue is empty. So this would be in the event where we have one element inside of the queue and we just removed it. So it means that the head pointer and the tail pointer should now be updated. So we are now updating the head pointer to point at -1 and the tail pointer to point at 0. Then of course we are going to return the element that would have been dequeued on line 52 there. Then you can copy the code and paste it inside of the evidence document. Moving on to part B, it says here that a shop sells computer games. Each game has a unique identifier, that is an ID of type string. Then there's a file called data.txt, qdata.txt rather. I have it right here. me see if I have the file somewhere here. Actually, don't have it in here. So it means actually this is the one queue data. So this is the queue data, right? Then the procedure read data is going to read data from the text file, and it sets it and inserts each item of data into the array queue. So we need to write program code that implements this under the function name read data. So my read data function starts at line 56 all the way up to line 72. So we are going to use exception handling. Let me close out of the file browser there. We are going to be making use of exception handling to handle any file not found or IO exceptions. It's supposed to be IO exceptions, not exception. It was not be resolved to a type. So this means I need to import the IO exception class. So let's see, it's Java .io .io exception right there. So this is the class that I need to import so that I can fix that error that I have going on there. So now if I scroll back to my read data function here, instead of handling a general exception, I'm now handling the IO exception. So you see that the error is gone. So we've taken care of that. All right. So we are reading from the file. Basically, what you're simply doing is we are creating a buffered reader object. But you need to remember that the buffered reader object actually takes a file reader object. So that's what we are doing here. So we are passing a file reader object on line 59 there to the buffered reader constructor before we create the reader object. Then with the reader object, we are making use of the ready function, which essentially checks to see if the current line is ready to be read. That is to say, a line is going to be ready to be read if it has contents or file contents, as it were. Then if we read the current line, we are simply going to trim it for any trailing white spaces. So this is going to continue. Rather, we are going to move on to check to see if the ID is not empty. Then if the ID is not empty, then we are simply going to enqueue the ID inside of our queue. Then this is going to continue until we have nothing left to read inside of the file. Then we can close the reader object. And of course, we are handling any exceptions that might arise at runtime when you are trying to execute this code, as it were. Then for this, you would go ahead and copy the code and paste it inside of the evidence document, and you'll get 6 marks. Then some game IDs appear in the text file more than once. So the program needs to total the number of items each game ID appears in the text file. So the record structure record data is the following fields. So it has this ID of a type string, store the ID, then and so forth and so on. So we are to create a record data structure, right? That is going to be called record data. So let's actually go ahead and look at that implementation going on there. So what I did in this case, I have a separate file right here called record data. Right, you can see here record data.java. So this is my record class declaration. So this is part C, item 2, item 1 rather. Right? So it says that we should have ID and total, which is an integer, a string and an integer. So you see those going on in here. So you have this ID string and total, which is an integer. Then of course you have the constructor for this particular record, because you cannot have a class like this one that you would have created as a record that doesn't have a constructor. So you would actually need to call a constructor that you're going to pass arguments when you create a record in your file. Then of course you copy the record code and paste it inside of the evidence document. Alternatively, what you could do is, if you don't want to do this, you can just move this file, rather move this code, you just copy this and paste it inside of the same file so that you can keep your code in one place. But then what you need to bear in mind is when you do that, let me just show you what happens. Yeah, remember that this class was marked as public, is it? So you no longer need to mark it as public. So you can essentially just remove this part right there. And we are now just working with all our files, or rather all our code in the same file, as it were. So only the main class should be public if you are going to take this approach. Maybe what I need to do also is to copy the comment, because I'm too lazy to type. So let me just copy the comment there and paste it right here. So this is where I'm declaring the record there. And then I can close out of that record file and just check to see if I've done everything. So yeah, that's just about it, and we'll be done with this part of the question. Moving on to item number 2, we are to write program code to declare records and number records. So records is in what array, and number records is going to be a global variable that stores the number of records currently in an array, and it's initialized to 0. So let's scroll here where we have the implementation for C item 2. So you can see that we have this record array. Right? It says here that records stores up to 50 items of type record. So that's what we're doing. The type is record data. And it's an array, and we're going to store it as the maximum size. And you remember earlier on, maximum size is a value of 50. Then this variable number records is supposed to be initialized to 0. So that's what we're doing here. And notice that these declarations are outside of any method, so that makes them global declarations because they're just inside of the class, but outside of any methods. So of course, you copy the code and paste it inside of the evidence document. Then moving on to C item 3, we are supposed to write, rather we are given pseudocode for this total data function. And you can see the implementation going on here. And I'm not going to go through it line by line. I'm just going to come here to find out what they want us to do. And they want us to write the procedure in program code for total data. So let's actually go ahead and look at that in action. So if you come here, you'll see that I have the total data function going on from lines 87 up to 107. So it essentially just matches the pseudocode that you are given. Is it so? It's now just a matter of translating the pseudocode into your language specific equivalent or your program code's equivalent. So whether you're doing Java, like in this case we're doing Java, so you should be able to translate this into Java. So you can see that it's a procedure, so it means it's just a void function. So you see that here we have the void return type, right? Then we have all those variables going on, and as well as just the if statements, right? Nothing fancy. They're just copying what they have going on in the pseudocode and applying it to this program code. So you can see that you have that. So yeah, I think that's just about it. Maybe just to go through I'm not going to go through it because I didn't even go through the pseudocode, right? When I was explaining, but I just went through the pseudocode when I was writing the solution. So you can just go ahead and do that. Then yeah. Then after doing that, we have the procedure output records that's going to output 1D and total of each record in records in the format. So this is the output that we are supposed to provide. So we have to write program code for this output records function, as it were. So let's scroll. I think it's up here. I did write it up here. There it is, right there. So output records, right? So we are simply iterating through the elements inside of the number records, is it? Sorry, iterating through the elements inside of the records. So the current index position, you're just going to output the ID, the total, so that we specify, we satisfy this notation right here. So we have ID is this, total is that, ID is this, total is that, just as they have going on this line there. Then our main method now needs to call read data, call total data, output records in that order. So let's actually go ahead and look at the main method. Let me just make a static import for system.out because I don't like how it's going on there. I've already done it, but just to be sure. Right, I'm already doing it there, so I can safely remove that system.out so because I don't need it, since I made a static import for the system.out function. So reading data from the file, we call the read data function as required here. Then next up, we call total data. So we are calling total data, but we're only going to call total data if the head pointer is not equal to 1 and the head pointer is less than the tail pointer, right? That's when we are going to be calling total 1. And we are going to also call output records. So we just call that function output records. Then I think the last aspect is to test the program. So we are going to test the program and take a screenshot of the output. So let me just go ahead and click open up my console. And then let me just compile and run the program, as it will. So it's inside the folder November. Let me just make sure that I type November with a capital letter in there. So it's November 23. V41, which is short for variant 41. Then I want to compile this class called question to November 23 variant 41.java. Right? So this should compile and run my program, as it were. So let's just go ahead and see that in action. Hopefully I got everything correct, and you actually see that yes, we have the output in the specified format, that is ID and total. And for that, you can go ahead and take a screenshot of this output and paste it inside of the evidence document. So yeah, that's just about it for this video. Hopefully you learned something, and I'll see you guys in the next one.